Hi guys, how's it going? Welcome back to the Majestic Masiakasaurus YouTube channel. As many of you probably have realized, this is actually the second part to a response I made to another YouTube video put out by another YouTuber explaining both flat Earth and the gravity hoax. So if you haven't seen the first part, I would recommend you definitely go do that before you come back here and watch this half. If you haven't already seen it, the first link in the description will be a link to that video where you can go check it out. Great, now assuming you've already seen that first video, we'll just go ahead and jump right into the second half. I think I said this last time, but really, I think it only gets better as we go along. We'll go through everything from the tides to why you don't experience the Earth spinning at 1,000 miles an hour, right down to some universal cringing at the end when we get to watch an anti-gravity music video. Anyway, without further ado, let's just jump right back into it. Please enjoy.
Alright, so here's essentially the argument they're saying. Why is it that gravity makes us stick to the Earth, but then also makes the Earth revolve or orbit the sun? We should do one or the other. Why is it doing two things at the same time? So let's go back to my really crude model of the sun and Pluto. Alright, so again, this is the sun, this is Pluto, not to scale. So the thing is, gravity is actually pulling on Pluto, the sun's gravity that is, and as Pluto comes closer to the sun, what you get is that it's coming in at just the right angle that does not get sucked right into the sun. You get this sort of slingshot effect. So this is how the slingshot effect essentially works, really basically. Pluto's coming in, but you can see he's coming in at a bit of an angle. He's not going right toward the sun. He's coming in sort of like this. I don't know why he's a he. I'm sorry. He's a he now. So Pluto's coming in at a bit of an angle, and as he gets closer, right, the distance is becoming less and less, so that the gravitational force the sun has on him is becoming stronger and stronger. So as he's coming in, the gravitational force is pulling him closer really faster, and he's accelerating as he's coming in here. And so he starts to turn, and you get this slingshot effect where he comes in and then is pulled right out again. But it's because he's coming in at this angle that he doesn't get pulled right into the sun. This gravity is just strong enough to pull him toward the sun, but he's coming far enough away that he just gets slingshotted back around again. So that's essentially what's happening, right? You have this elliptical orbit because he's coming in, and as he gets closer, the slingshot throws him around the corner again, and then he goes farther away, moving slower, but gravity's still pulling on him, so he does turn and come back, and you get this elliptical orbit. So essentially my point is gravity is doing both of these things at the same time, sticking us to the Earth versus making us orbit the sun, because it's just the force that pulling on other objects. That's why we get asteroids that sometimes do actually land on the Earth, that are not coming in at as much of an angle as we would like to get slingshotted away, but just get rammed into the Earth. The most famous, of course, is the KT mass extinction that wiped out the dinosaurs about 65.5 million years ago. Now, the reason that Pluto does not just continually get closer and closer to the sun, or that our moon does not revolve around us and get closer and closer and eventually hit us, is because there's actually another force going on here. I'm sure you guys know where I'm going with this, but have you ever taken a bucket, an open air bucket with no lid on it, filled it like halfway with water, and spun it around 360 degrees so that halfway up, it's like the water should be falling down, but the water actually stays in, and you can bring the bucket down and not get yourself wet. That same force, which keeps the water in, apparently defying gravity, I believe called centrifugal force, is the same reason that the moon is staying at about the same place, distance-wise, from the Earth. Centrifugal force essentially means that as an object moves in circular motion, it is exerting force outward, right? So as that bucket is circling up, its force is exerting, the water is exerting a force outward, and so it actually stays against the bucket as it goes around. So the reason that our moon orbits us, or that we orbit the sun, is because the sun's gravitational pull is keeping us in line close enough to it, but the centrifugal force that we're making as we do that circle around the sun is pushing us outward as the gravitational pull of the sun is pulling us inward. That is essentially why we continue to circle at about the same distance and not get sucked right into the sun. I hope that kind of makes sense. It's a little bit difficult to explain, but that's why gravity makes things orbit sometimes and other times stick to the planet.
What sort of magic is gravity that it can glue people's feet to the ball Earth while causing Earth itself to revolve ellipses around the sun?
It's not magic, it's science.
The two effects are very different, yet the same cause is attributed to both.
Again, the two effects actually aren't that different. It's just what happens when you get centrifugal force also pushing this outward force in combination with gravity, a pulling force. Sometimes results in orbiting rather than just being pulled right in.
Furthermore, This magnetic-like attraction of massive objects gravity is purported to have can be found nowhere in the natural world. There is no example in nature of a massive sphere or any other shaped object, which, by virtue of its mass alone, causes smaller objects to stick to or orbit around it.
So, no. The reason that you don't see anything on our planet revolving around something else just due to mass is because, like I said, my gravitational pull is extremely small because I am very small. But literally everywhere else in space you see gravity holding everything together. We're orbiting the sun. Our moon is orbiting us. That's why asteroids sometimes get too close and get pulled into our atmosphere. Gravity is everywhere, and if you look in nature, again, that's gravity.
There is nothing on Earth massive enough that it can be shown to cause even a dust bunny to stick to or orbit around it.
And that's because everything on Earth is not nearly massive enough to have a gravitational pull strong enough to pull anything else on Earth to it. Especially when everything on Earth is being pulled by the extremely strong gravitational pull of the Earth itself. And to quickly address this thing with the bee and the duck before, guess what? Gravity's still pulling on that bee as it's flying around. It's just exerting enough energy to flap its wings fast enough that it can actually stay above the ground. But like my arm earlier, as soon as that bee stops flapping its wings, it's gonna fall.
Try spinning a wet tennis ball or any other spherical object with smaller things placed on its surface, and you will find that everything falls or flies off, and nothing sticks to or orbits around it.
Once again, that's just because the tennis ball is extremely small, and its gravitational pull, therefore, is also almost nothing. However, though, you can also see a great example of centrifugal force in this image. As the tennis ball spins, centrifugal force creates this outward pushing force, which then means all the water droplets sitting on the tennis ball fly outward, as you can see in the picture.
To claim the existence of a physical law without a single practical evidential example is hearsay, not science.
Yeah, it would be, but guess what? Gravity's not like that. Gravity is everywhere. It's been proven thousands of times. Oh dear God, I'm only halfway through this video.
Newton also theorized, and it is now commonly taught, that the Earth's ocean tides are caused by gravitational lunar attraction. If the moon is only 2,160 miles in diameter, and the Earth 8,000 miles, however, using their own math and law, it follows that the Earth is 87 times more massive, and therefore the larger body should attract the smaller to it, and not the other way around.
Yeah, that's why the moon orbits us and not the other way around. We are attracting the moon, but the moon is also big enough and close enough that it does have some effect on the water on the Earth.
If the Earth's greater gravity is what keeps the moon in orbit, it is impossible for the moon's lesser gravity to supersede the Earth's gravity at Earth's sea level, where its gravitational attraction would even further out-trump the moon's. Not to mention the velocity and path of the moon are uniform, and should therefore exert a uniform influence on the Earth's tides, when in actuality the Earth's tides vary greatly.
Okay, so a few things are going on here. First of all, the moon's gravity is not superseding our gravity. That's why the water stays on Earth. The moon's gravitational pull is just enough that it can affect the tides of the Earth without pulling the water off the surface, because the Earth is more massive, the water's going to stay on the Earth. Also, of course, the tides vary greatly. The moon does not stay in the same place all at one time. It's orbiting the Earth, meaning that at some times it's closer to different water as it goes around the Earth than others. Also, the moon is not the only thing which affects the tides. Believe it or not, the sun, which is extremely far away, is also huge and does actually have some effect over the tides, though just not nearly as much as the moon does, because the moon is a lot closer. For example, you get really high tides when the sun, the moon, and the Earth are all lined up, because you have the sun and the moon pretty much acting on the same place on the Earth at once, and then you get really high tides there. So yes, even though the gravitational pull the moon has on the Earth is uniform, because it's orbiting the Earth and because it is not the only thing which affects the tides themselves are not uniform.
Furthermore, if ocean tides are caused by moon's gravitation, how is it that lakes, ponds, and other smaller bodies of standing water remain outside the moon's grasp, while the gigantic oceans are so affected?
Again, actually no. Lakes and other standing bodies of water that are significantly smaller than those of the oceans actually are still affected by the moon's gravitational pull, though their tides are just smaller because they are also smaller.
Heliocentrists claim the ball Earth is perpetually spinning on its axis at a mind-numbing 1,038 miles per hour, or 19 miles per second, and somehow people, animals, buildings, oceans, and other surface phenomena can stick to the underside of the spinning ball without falling or flying off.
Oh, another classic misinformed flat Earth assertion. Again, there's no underside of the Earth. Let's just please stop doing that. I'm going to try to explain this as quickly as possible because I really could just kind of rant about this all day. But essentially, here you go. Galileo had this simple proof, like literally hundreds of years ago, for why we do not experience the spinning globe. I'm going to use essentially a more modern version of his experiment involving a horse to try to explain this to you. If you've ever been on a car moving on a high-speed freeway, you'll know what I'm talking about. Next time you go on a freeway, take something small with you, like a little ball, or I'm holding a pack of tissues, doesn't really matter. And when you're sitting in the back seat on this long drive, toss the object up and down a little bit. You'll notice that even though you're going 60, 70, 80, who knows how fast on the freeway, the object itself is not going to go up and then essentially fly backwards as you should be moving forward without it. Just like you don't really notice that you're going 70 miles an hour on the freeway, the object, or the tissue packet, or the ball, or whatever you're throwing, also doesn't really seem to notice. It just seems to go up and down as though you were not moving at all. The reason for this is because you are in a contained, closed environment, the car, as it's going really quickly, so anything inside that seems to operate as though it's really not moving at all. In reality, what's happening to the object that you're throwing is that as the car is moving this way, the object is actually doing this, right? It's doing these little humps. But because everything inside the car seems as though it's really not moving, it to you appears as though it's only going up and down. The same thing is applicable to our Earth. Everything that's happening on the surface of the Earth is a contained environment enclosed by our atmosphere. So as the Earth spins around, when I throw this thing, this tissue packet up and down, it really is going like thousands of miles an hour. But because everything else is doing the same, it feels as though nothing is moving, and it looks as though the tissue packet is only going up and down, when it really, just like the car, it's doing these. I hope that sort of makes sense. Try it out next time you go on a freeway. It does work, and that pretty much explains why you don't actually feel anything, even though the Earth is revolving thousands of miles an hour.
Take a ride on the Gravitron at your local amusement park, however, and notice how the faster it spins, the more you are pushed away from the center of spin, not towards it.
Yes, because this Gravitron of yours is actually not gravity, it's centrifugal force, which is literally what I was talking about just a few minutes ago. As the thing spins, you are pushed to the outside. That's not gravity. That's the thing that keeps stuff in orbit against gravity.
Even if the centripetal, inward-pulling force of gravity did exist, which it does not, the centrifugal, outward-pushing force of the ball Earth's supposed 19-mile-per-second spin would also exist and have to be overcome, yet neither of these opposing forces have ever been shown to have any existence outside the imaginations of heliocentric scientists.
Again, no. Go home, fill up a water bottle or a bucket with water and do the spinny thing. It works. That's centrifugal force, which you just named. I really don't want to keep repeating myself, so I'm not going to, but that is the reason that the water thing works and why we stay in orbit around the sun, because as we move in a circle, we're pushing outward. The centripetal, as you pointed out, gravitational force of the sun is pulling us inward, so we stay at the same distance orbiting the sun.
Astronomers claim to have measured all the planets' distances, shapes, orbits, weights, relative positions, and times of revolution, all based on the law of gravitation, and without gravity, their entire cosmology folds under its own weight.
Okay, so aside from what he's saying, really? Meanwhile in Australia? Oh my god. Yeah, just because Australia is on the bottom of the map the way we usually portray it, does not mean it's the bottom of the Earth. Please stop. In space, there is no down or up. Our Earth is a sphere, so there's only toward or away.
Without gravity, people cannot stand upside down on a ball Earth. Without gravity, the Earth and planets cannot be revolving around the sun. Without Newtonian gravitation, Einsteinian relativity, Copernican heliocentricity, and the entire Big Bang ball Earth mythos cannot exist and falls to pieces. Gravity, both metaphorically and quite literally, just does not hold any water. Not as a sound theory of cosmology.
Okay, so I'm gonna just go ahead and use this image against you. Now what? Looks like your dude sitting on the flat Earth is on the bottom side of the flat Earth. How's he not falling off? Because apparently gravity doesn't exist. It's because there is no up and down in space. Please stop. Sorry, I'm not really making any comments about what he's saying. Essentially, he's just telling us how important gravity is to the theories of everything.
And not as a law supposedly responsible for holding in the world's oceans.
Again, gravity is actually pulling down on those balloons, just not as much as it's pulling down on the air around it, so they appear to rise and defy gravity. Okay, I honestly forgot there was like a music video at the end of this. So, as though you thought it couldn't get any worse, for the next 3 minutes is essentially an anti-gravity music video. I don't think it says anything important that I need to respond to that I haven't already, so I'll watch it really quickly, but it probably won't make it into my response here.
A few moments later.
What's happening? Did I have that in my hair the whole time? Nice. Yeah, you're welcome for not including that in this video. If for some reason you'd like to go kill off some brain cells of yours, I'll leave a description. I can't talk anymore. I'll leave the link in the description. Go knock yourself out. I wouldn't recommend it. Okay, actually, one last thing. There is one thing I forgot that the music video does say that I like to address. At one point across the screen, it does flash the words, "It's a con trick." This is something that, again, you hear from flat earthers all the time, as though it's all sort of some big con for what reason? That's my question. What on earth does NASA, the governments of the world, scientists, anyone, have to gain from keeping us all in the dark about us living on a flat earth with no gravity? It doesn't make any sense. I've never heard a good response. Why can't you just tell people we're living on a flat earth? If that's the way it is, why doesn't NASA just tell us? If they have proof for it, that's what they would tell us. Anyway, I think that's it. I think I'm done. Thanks for sticking around to watch the whole thing if you're still here. I hope this isn't too long of a video. I'll try to chop it up, edit it a little bit, make it digestible for you. But thanks for sticking around and watching. This has been interesting. Turns out the answer to the question how gravity works on a flat earth is it doesn't. Gravity doesn't exist, apparently. Well, as usual, thanks so much for sticking around. I hope to see you back on the Majestic Masiakasaurus channel in the future if you like this sort of thing. If you did like the video, you should give it a like, because that makes sense, right? You like the video, like it. Anyway, it does help. I appreciate it. Thanks for sticking around. Hope you see you in another one. I won't keep any more of your time. Go have a good day. I'll see you later. Peace out. It's not magic, it's science.